So today we will discuss another problem. The question is given here. Find the transfer function or control ratio C by R. The control ratio C by R is actually same. That is actually we have to find the transfer function of the given system. So you can see the given system is in block diagram format. So you can approach using block diagram reduction rule. That is one way or one method. But if we can also convert the block diagram into signal flow graph. That is another method. If the method is not specified, we can convert the block diagram into signal flow graph. So today in this lecture, I will explain how to convert a block diagram into signal flow graph first. So you can see input signal are here. So all the input and output that should be represented by nodes. So I am representing R as one node, output C as another node. Now if you see, there are two summing points. These two summing points again I am represented by two nodes. One is this node and another one is this node. Okay, two summing points are represented by two nodes. This node and this is the first summing point, node corresponding to first summing point, and this is the node that corresponding to second summing point. Now if you see, there is no block in connected between the input and this summing point. Since there are no blocks connected here and it represented with a positive sign, I can mark the gain of this branch as 1. Since there is no block in between the input and summing point and it is represented with a positive sign, I can mark this transmittance of this path as 1. Also if you see here, in between these two summing points there is again no block connected here, and it is also again represented with a plus sign. So in between the node represented to representing the first summing point and second summing point, I can mark the transmittance with a unity or positive transmittance with 1. Okay, the value of the transmittance or gain is 1 here, positive 1 or plus 1. Now we can see the arrow. So corresponding to the arrow that is given in the block diagram, you can also indicate the arrow mark here. These arrows are from left to right. Here also arrow is same, left to right. So I can represent that arrow here. Now here you can see another block, another summing point. Okay, in between this summing point, second summing point and third summing point, there is a block G1. So I am representing this summing point as the next node. Okay, this summing point I am representing as the next node. So these summing points and the points of takeoff point or pickoff point can be represented as a single node in signal flow graph if two adjacent pickoff point and summing point are coming. When you convert it into signal flow graph, you can convert these two as a single node because we are taking branches from that node only. That is why we can take this corresponding to this summing point and this branch, we can represent it as a single node. So you can see here, in between this summing point and this summing point, there is a block with transfer function G1. So I am representing that block with the transmittance of that branch with a gain G1, or transmittance of that branch is equal to G1. So this is also represented here. Okay, transmittance of that branch is represented as G1, and corresponding to this summing point and pickoff point, we can represent it as a single node because when two adjacent summing point and breakoff points are coming, so we can represent these two as a single node. That is a representation rule. Now in between this pickoff point and another pick-off point is there is a transfer function g2. So this pick-off point I am representing with another node, and in between these two nodes there is this transfer function g2. Now in between this pick-off point and summing point there is again another transfer function that can be represented as g3. So you can see here this summing point and two pick-off points are represented by a single node. Okay, this summing point, last summing point or fourth summing point, and these two pick-off points are represented by a single node. You can represent these three summing points and two pick-off points as a single node when you represent it in SFG. And in between this I can write the gain as G3, and the output, of course output C, that is represented by with a node C. And in between G3 and C, since there is no blocks, I can represent it as, that is these three are represented as one node, and in between these nodes since there are no blocks, I can represent it with a 1 or unity sign. Now if you see here, from this point there is a block G4, a forward path transfer function is coming here. G4 is coming. So corresponding to this summing point of pick-off point, my node is this, that is before G2. There is a forward path that coming here, and that can be represented as, the transmittance can be represented as G4, and the direction should be given in the block diagram. Now if you check, in between G2 and G3 there is a pick-off point, and that is coming to the second summing point. So what is the node corresponding to second summing point? That is this, just before G1. Okay, the node corresponding to this summing point is just before G1, and to this node there is a feedback path coming with transfer function h1. So that feedback path coming in between G2 and G3. So what is the node in between G2 and G3? That is this node. So from this node there is a branch or feedback path is coming with transfer function h1. So when you write this transfer function transmittance, you have to check the direction or the sign here. Here you can see this is a positive feedback signal. For positive feedback, the transfer function is coming, feedback path transfer function is having a positive feedback. So we can write simply h1 here. Since there is no sign here given, we can take it as plus h or plus h1. Now if you check, from this node there is another path is coming, that is h2 is coming, that is in between G1 and G2. What is the node in between G1 and G2? That is this. So from this node, that is corresponding to after the branch G3, there is a feedback path coming with a gain h2, and this is also having a positive feedback. So this can be represented by h2 or plus h2 or simply h2. Now if you check, there is another feedback path is coming to the first summing point, and this feedback path is not having any transfer function. That means it is having a unity feedback, or the feedback path transfer function is unity. Since there is no block is given, we can take it as a unity feedback path, and it is actually a negative feedback path because there is a minus sign. So we can represent that path, that from the node, a branch that starts from here and ending to the node corresponding to first summing point, and we can represent it as a, since there is negative unity feedback, we can represent it as a -1. So this is the signal flow graph corresponding to this block diagram. Now the approach is to find the forward paths. So if you see, if you check, we can see that the first forward path is this straight line starting from R to C. So its path gain will be 1 into 1 into G1, G2, G3. So the first forward path gain is G1, G2, G3. Now the second forward path is starting from R, it goes here to this node and through G4. So the second forward path is starting from R through G4, it coming to the output C. So the second forward path transfer function is 1 into 1 into G1 into G4. So second forward path transfer function is G1, G4. Now we have to check whether there is any feedback loop. So there is a first feedback loop that shows here G1, G2, H1. That is first feedback loop. Now there is another feedback loop that is G1, G2, G3, H2. G2, G3, H2 is another feedback loop. Now if you check a feedback loop starting from this point, that is 1 into G1 into G2 into G3 into minus 1. That is minus G1, G2, G3 is another feedback loop. That is starting from here, it travels here and returning to this node through minus 1. So minus G1, G2, G3 is another feedback loop. Now what are the other feedback loops? That is, if you check here, you can see that from this node the path through G4, path through the branch of transmittance G4, that is starting from here G4, it is coming to this node through H2. That is G4 H2 is another feedback loop. And another feedback loop is starting from this point 1 into G1 into G4 into minus 1. That is minus G1 G4. That is another loop. So there are totally 5 loops. And if you check all the loops, that is this loop and these loops are touching loops, and this large loop is also touching with all other loops. So you can see that there are no non-touching loops here. So our delta or determinant will be 1 minus of sum of loop gains of all individual loops. That is 1 minus of loop gains of all individual loops. We can see here 1 minus of loop gains of all individual loops, that is seen here, or that is written here. And since there are no non-touching loops, our delta 1 and delta 2 will be equal to 1. If there are no non-touching loop, we can simply write it as, if the non-touching loops are 0, or if there are no non-touching loops present in the signal flow graph, we can write delta 1, delta 2, delta 3, etc. is equal to 0. Now we have to write the equation. So our equation is C by R equal to sigma I is equal to 1 to n Pi delta I divided by delta. So what is the, how many forward paths are there? We can see here there are 2 forward paths and n is equal to 2. So our control ratio or transfer function is C by R is equal to P1 delta 1 plus P2 delta 2 by delta. That is represented here. So this is our final transfer function. Thank you.